morning to all. I am Dr. N. Senthil Kumar, Assistant Professor, working as Assistant Professor in IT Department. I am handling the subject of CCS355-Neural Network and Deep Learning Regulation of 2020-21 for third year IT Department students. So now we are going to discuss about the unit number 2 of our neural network and deep learning, associative memory and unsupervised learning networks for unit title. So here we are covering the topics for training algorithm for pattern association, for auto associative memory, hetero associative memory, bidirectional associative memory, simply called as a BAM, half-field network, iterative associative memory networks, temporal associative memory networks, for fixed weight competitive networks, and coherent self-organizing future map for learning networks, vector quantization for and counter propagation networks. Last but not least, adaptive resonance theory network for neural network. So this is we are covering the first topic for auto associative block diagram. So here called as a argument register A, key register for K. So input we are given as a 3-part input, read and write block. So 3 input blocks we are given as a input data. So here covering the block diagram or associative memory array logic block. So we have to covering as a memory pointer as a array logic for using as a memory device and some memory match register. If we are giving any register, for example for giving any keyword for capital A or capital X, so depending upon the capitalization or letter, it will cover as the capital A only covering the key register for K, A for alphabet. If it is matching with the algorithm for text register, it will give the output. Otherwise, you are giving as a small capitalization or some other keywords. You are putting as a assign as a register as some other letters. It will not give you your output. This is the training algorithm for learning model for auto associative memory block diagram. It's a one directional associative memory. So pattern associative memory. Pattern association is the ability of a system to store patterns and recall them later and give partial noisy or related input. The system does not search by address like RAM. Common in neural networks and biological memory models. Example for seeing a blurred image of a letter A and still recognizing is as capital A. Associative memory retrieves stored information based on similarity or association with the input pattern. Types of associative memory is dealt with 2 types of memory. Auto associative memory for input pattern equal to output pattern. Hetero associative for input pattern is not equal to output pattern. So applications of auto associative memory deals with pattern recognition, error correction method, image restoration, optimization problem dealing with security purpose or some other authentication purpose, cognitive modeling and signal processing for voice communication or natural language processing or sequential vein pattern analysis for using this auto associative memory. Next we will deal about the architecture of hetero associative memory. Here we are giving as in n number of input x1 to xi up to xn is called as input data, and it deals with the x1, xi and xn with the network of dealt with y1, yj, ym is the input vector equal to output vector. It deals as a multiple network. It's a multi-directional. Is both the input for dealt as a one direction for only feed forward network. Here we are called as a weight as well as input. We are multiplied with the output of y1, yj and ym. So it is dealt with the multi-layer network. Input of all the block covering with the what are the input given. It's covered with the input with the hidden layer with respect to output layer. So these are the input network, input layer, output layer and hidden layer covering this hetero associative memory. Hetero means it's the 2-dimensional vectors. So hetero associative memory network deals with the input pattern and the output pattern are different. It stores pairs of patterns and recalls the corresponding output when an associative input is presented. The network learns associations between two different pattern sets on presentation of an input vector x. It produces a related output vector y. Works even if the input is partially or noisy. Applications of heteroassociative memory deals with pattern translation, language processing. Third, control system for either uh, electrical signal or with respect to control system deals with the pattern analysis, signature analysis, voice analysis. What are the control we are giving this systems called as a control system application. Next one is signal processing applications. Depending upon the traffic congestion, traffic concentration, network protocols, network layers, signal processing analysis we are using, and database retrieval for false or for currently working as a threatening of cyber security data. We are creating as a original data as well as false data. We are training and testing data. We are analyzing this type of application memory network. We are using this heteroassociative memory. Next we deal as a bidirectional associative memory, simply called as a bidirectional BAM. BAM is a neural network that stores associations between two different pattern sets and is capable of retrieving one pattern when the other is presented in either direction. Characteristics of a BAM: bidirectional information flow, stores pattern pairs, stable convergence, symmetric weight usages, and noise tolerant to same extent. So bidirectional information flow for multiple layer network is a multi-layer perceptron analysis using as a bidirectional associative memory. Applications of bidirectional associative memory: pattern association, image or text association, code conversion, signal mapping, recall of related data information is called as a bidirectional application. Here the bidirectional associative memory architecture, we are giving as a two type of network architecture will be there. Only for forward direction, another one was backward direction. So forward means x1 of p, x2 of p up to xt of p into xn of p. Here dealt with a time network t plus 1 or p plus 1 network. Here cover as a p means forward direction, p plus 1 is backward direction. Next we deal with a temporal associative memory network architecture. Here we deal as a future extension of F0. Here it called as a three types of layers: convert block, rest block, and rest block 1 of I block. Conversion, batch normal pre-layer network, and future channel will be there. Conversion and B and middle layer. Restore block means channel C, channel CB4, channel CB4 into CB4, CB4 equal to C. Here we are convolution of C type of network, three types of layer network here called as a temporal associative memory. Temporal associative memory. A temporal associative memory network is a neural network model that associates an input pattern at time t with another pattern at a future time t plus 1, t plus 1, enabling sequence learning and prediction. Characteristics of temporal associative memory: stores ordered patterns, captures temporal correlations, sequence recall, and predictions, context dependent memory, sensitive to initial conditions. So these are the pattern we are analyzing using captures of image or captures of text or captures of recall application or accuracy and content of memory based analysis. We are using a temporal associative memory network. Here applications of temporal associative memory: speech recognition, handwriting recognition, time series, list, motion, and tracking application. Next to cognitive self-organization with math architecture. Here we are called as a three type of network: input layer and hidden layer and output layer. Input deals with the x1 to x of n of layers, x1 to x to m argument of 200 input variables they are given as the input layer. Output layer is covered as only one direction is a feed forward analysis for using as a mapping network for using as a 5 cross matrix analysis or minimum starting of 5 cross 5 matrix analysis we are using as a convolutional neural network. Here using as a unsupervised neural network that maps high dimensional input data onto a low dimensional, it's a one dimensional or two dimensional grid while preserving the topological relationships of the input patterns. Input vector is presented, distance between input and each neuron's weight vector is calculated. Neurons with the minimum distance becomes the best matching unit BMU. BMU and its neighbors updated their weights. Advantages of SOM architecture: visualize high dimensional data, cluster similar input together, preserves spatial relationships together. Next we are covered as a counter propagation network. We are given as a same input vector given as a unsupervised layer and supervised layer, and output called as a desired output called as a layer. Here we are dealing with the three types of layer: input layer, hidden layer and output layer. The input layer covered as a unsupervised network and the hidden layer covered as a supervised network, both along with the combined with a supervised and supervised learning model given as a output for output desired output. Its architecture is a hybrid neural network that combines unsupervised learning and supervised learning to perform fast input-output mapping and classification techniques. So here working steps for this counter propagation network: present input pattern, cognitive layer selects winning neuron, and gross breadth layer generates the output. Weights update in both layers. So applications of this counter propagation network: pattern classification techniques, function approximation techniques, speech recognition for voice to text or text to voice recognition, and signal processing analysis, decision making of systems using as a AI or DNN model using this counter propagation network using these applications. Thank you.